Hey, in this video, I want to talk more about limits. We're going to infinity. Infinity is so cool. So first off, the thing you need to remember, the limit as x goes to infinity of 1 over x is 0. A nice way to think of this is imagine you have one keg of beer and all these people want to drink. The one keg divided by the lots of people means you're not going to get much beer. So keeping this in mind, let's look at a couple limits. Let's say we have the limit as x approaches infinity of x plus 1 over 3x minus 7. I want to use the fact that the limit as x approaches infinity of 1 over x equals 0. So I'm going to multiply this expression by 1. And the 1 is going to be 1 over x all over 1 over x. Multiplying through 1 over x times x gives me 1, 1 over x times 1 gives me 1 over x, etc. The 1 over x's and the 7 over x, those goes to 0. Those go to 0. The only thing that survives is the 1/3. Let's try another one. Suppose we have x plus 2 over x squared minus 5x plus 1. I'm going to pull the same trick. I'm going to multiply by 1 over x squared all over 1 over x squared. Notice when I multiply through, I have 1 over x plus 2 over x squared. On the bottom, I've got 1 minus 5 over x plus 1 over x squared. You may be asking yourself, how does she know what x power to use? You will always choose the highest power of x in the denominator. I want to make sure I have a number here. So I can't divide by x cubed because then I have all these zeros on the bottom and limit over 0, that's not cool. We want to have a constant number and then everything else goes to 0. So notice here I have a 0 plus a 0 over 1 minus 0 plus 0. So the limit is 0. Let's check this one out. X squared minus 2 over x plus 1. Since the highest power of x on the bottom is 1, that's what I'm going to multiply by. Now, I still have an x on top. The 2 over x is going to go to 0. The 3 over x goes to 0, but I'm left with x over 1. And as x goes to infinity, this limit goes to infinity. Now, I want you to get to the point where you can look at these things and not go through all this extra algebraic crap to figure out what the limit is. It's pretty straightforward. As x goes to infinity, if the top is going to infinity and the bottom is going to infinity, the question becomes which one is going faster. If the faster one is on top, you're going to infinity. If the faster one is on bottom, you're going to 0. If they're about the same speed, then you'll get some constant. So here is my theorem. Suppose I have two polynomials, f of x and g of x. F of x starts with am x to the m, which is the important part, and g of x starts with bn x to the n, the important part of g of x. The limit of f of x over g of x, well, let's see. It's going to be 0 if m is smaller than n, which means it's got a smaller degree. It's going to go slower. However, if n is less than m, that means the top is going faster than the bottom, so you'll get infinity. If they're the same, then you have a ratio of those leading coefficients. You have a to the m over b to the m. Because they're going at about the same rate, so they're going to head toward those leading coefficients. What if you don't have a polynomial? That's okay. You could still talk about the degree of the numerator and the degree of the denominator, but just take the square root into account. As you go to infinity, 9x squared plus 2x minus 1 basically is the same as 9x squared. So the square root of that is 3x. That part, 2x minus 1, doesn't make a difference when you're at 50 gajillion trillion huge-ass number. Okay. The 9x squared is what's driving this expression. On the bottom, 3x plus 5, once you get to a gazillion, billion, whatever number is your biggest number in your head, that 5 doesn't mean anything. So the limit as x goes to infinity of the square root of 9x squared plus 2x minus 1 all over 3x plus 5 is pretty much the same thing as 3x over 3x, which is 1. What about the other functions? Well, some of the other functions that we know. A to the x is the fastest of all the functions, and x to the n, meaning all the polynomials, that's the next fastest, and the slowest is, well, it's not the slowest. The slowest function that actually still increases is log base a of x. Now for all of these, I'm assuming a is greater than 1, because otherwise you've got 1 over a to the x. It gets weird. I'm assuming that these are all increasing functions. And what else do we have? Well, we have constants, which don't go anywhere, sine and cosine, which really don't go anywhere. They're like fish kind of flopping around in the sand. So they're slowest of the slow. So we should be able to look at these things and kind of figure out what's going on, or just give us an intuition of what to expect. So consider cosine x over x squared plus 3. The top is just vacillating between -1 and 1, but the bottom is exploding. So this limit is going to be 0. Let's say we have this. We've got 2 to the x minus x squared over x to the 20th plus 5. On top, 2 to the x is in charge. On the bottom, x to the 20th is in charge. That could be x to the 30 billion. I don't care. The top, 2 to the x, will be faster eventually. So this limit is going to go to infinity. What if you're going to negative infinity? Does that make a difference? Well, yes it does. I kind of skimmed over something when I first talked about the square root. Let's get a little bit more precise here, because since we're going to negative infinity, it makes a difference. The square root of x squared is officially defined to be the absolute value of x. And the absolute value of x is x as long as x is positive, but it's the opposite of x if x is negative, because you need to counteract the negatives. And since we're going to negative infinity, the absolute value of x will be negative x. So that means we have 9x squared plus 3x plus 5 under the radical is approximately equal to 9x square root of 9x squared, which equals to the absolute value of 3x. And 7x plus 1 is about 7x. So my limit becomes the limit as x approaches negative infinity of the absolute value of 3x over 7x. But the absolute value of 3x is negative 3x. So now looking at my leading coefficients, I get negative 3/7. The takeaway, when you've got x going to infinity and you have a ratio, you want to know who's going faster. If you have the difference of infinities, well, that's something we'll get into next time. That can get kind of funky too.